the UKMT Junior Maths Challenge from 2021. You get 5 points, I think, for the first 15, 6 thereafter, and you don't lose anything for guessing in this paper. So you may as well guess every single thing you're unsure of. Let's get straight into it. So yeah, nothing too fancy going on here. Let's do the first two things first. Now actually, when you subtract these two numbers, notice how if you just swap the order, you just put a negative in front. If I were to swap the order, the difference between every digit is a 3, so it becomes 333, and then you just put a negative in front. That's how I did it in my head at least. Anyway, then you take negative 303, add it to this. Of course, this is the same as this minus this, and again, just take 3 off every digit here. You end up with 4, 5, 6, I believe, and that would be our answer. You probably weren't so fancy with things, you probably didn't even understand what I was talking about. But however you want to do that question, just do it. Columns, additions and subtractions probably were the best way to go. Anyway, Brianna has £20 all in 5p coins. Now I know it takes 25p coins to make a pound because 2 5p coins is 10 pence, times that up by 10 to make 25p coins is a pound. Now of course if that means she has £20, we times this by 20, we times this by 20 to get 400 5p coins in £20, so that's this half done. Now this bit, well again, it takes 5 2p's to make 10 pence. So therefore it takes 50 2p's to make £1, just multiplying it by 10. I've got to have £50, so let's multiply this by 50, which means multiplying this by 50. Of course, 5 times 5 is 25, add the 2 zeros, it's the same thing I did here for this 400. Add those two results together and we get 2,900 coins in total. Number 3, so follow BIDMAS here. BIDMAS suggests that you do division first. It doesn't actually matter with division and multiplication, as long as you do those before things like subtraction and addition. So let's times these two things first together to make 6, and divide those to make 0.8. I just kind of know that result is 0.8. If you need to use a bus stop to verify that, go ahead. Now we can do addition and subtraction, just go left to right here. So do 1 minus 6 first, which is also what BIDMAS says anyway, to make minus 5. In fact, no, it doesn't. BIDMAS says to do plusing first. But just go left to right if you see something like this. So 1 minus 6 is minus 5, plus 0.8 is minus 4.2 as our answer. Good. Number 4, multiples of 11. So yeah, I could write out the 11 times table all the way up to here. I'm not going to. What I'm going to do is I'm going to say, well, 110 is definitely a multiple of 11 because it's 11 times 10. And now from here to here, I would need another 77. But 77 is also a multiple of 7, right? Like I know, sorry, multiple of 11. I know all the multiple of 11 below 100 because they're all just the double digit numbers. 22, 33, 44, 55. So if I can get near these numbers, like these two, and then just look for the difference. The difference here is 77. This is a multiple of 11. 77 is a multiple of 11. Therefore, this is what? Going to be 11 times 17, I guess. That's going to be fine. Here, the difference is 46, which isn't a multiple of 11. So that's not going to be okay, because it's 10 times 11 plus something that's not a multiple of 11 to get to here. From here to here, I could say is 123, but again, or 100 and whatever it is, 43. But again, if I actually just double this, I can get closer to my target number. And now I can say, well, this is definitely a multiple of 11 because it's 11 times 20, because that was 11 times 10. There's a 33 difference here, which is a multiple of 11, I know, so that is definitely working. Again, get closer to your target number, so double this up again to find another multiple 11 that's quite close. The difference here is 55, which is a multiple 11, so that's definitely going to work. And this one is close enough to here, difference 22, which is a multiple 11, so that one works as well. So in fact, they all work except the second one, and that's how I did that one. Number 5. When I walked 25%, sorry, 20%. So what I did here, I'm not sure what the best way of doing this question is. Here's the walk to school, and I said after 20% of it, which is this far, roughly, I have 1,200 meters more to walk than when I have 20%. So let's get to the point where you have 20% remaining. So here's the point where you have 20% remaining. Now, when you're here, you have 1,200 more to walk than when you just have 20% left. So this distance here is 1,200 more than this distance here. But of course, these two distances just sort of cancel. So the 1,200 must just be this distance in here. And because there's 20% here, 20% here, this middle bit is 60%. So I can say 1,200 is 60%. And now I just need to work out what 100% is, because that's the entire distance from home to school. Now there's various ways you can do this. I just divide it by 6. 12 divided by 6 is 2, so this is just 200. Divide by 6 is 10, and then just times by 100 to find 100% is 2,000, which is 2 kilometers, I guess. Or actually, no, there's no units here, but anyway. So, oh yeah, there is meters, so 2 kilometers, I guess. 6. So, sure, let's put these fractions together a little bit. So 2 minus a half is 1.5. 3 minus a third is 2 2/3, and 4 minus a quarter is 3 3/4. Now I'm going to make these all into improper fractions. So 1 times 2 is 2, plus 1 is 3. 2 times 3 is 6, plus 2 is 8. 3 times 4 is 12, plus 3 is 15. And now, to multiply fractions, which is what is in here, right? These are just multiplying signs in between brackets. You can just multiply them on the top and multiply them along the bottom. Now let's do these two first. 3 times 8 is 24. 2 times 3 is 6. 24 divided by 6, though, just before we start multiplying some more numbers. 24 divided by 6 is just 4. And now if you're comfortable with fractions, you can just cancel this and this and you get the answer of 15. Or do 4 times 15, because this is like 4 over 1 times this. 4 times 15 is 60, but then 60 divided by 4, as I said, is 15, and you get your answer eventually. So yeah, probably lots of different ways of thinking about that. I don't know whether I did it in the way that other people would, who knows. So okay, we have this question here. What is angle PTS? So that's all of this angle here. I have part of it as 36. All of these lines are going to be very helpful because they tell me these are all isosceles triangles. So there's 180 degrees in a triangle, so 180 minus 36 is 144. And that's shared equally between these two angles because it's isosceles, so these two angles are the same. So 144 divided by 2 is 72. So these triangles are 72. Now, angles on a straight line add up to 180. So 180 minus this must be this, which is 108. And do the same thing again. Because we've got another isosceles triangle here. So 180 take away 108 is 72. Again, we just did that one. Divided by 2 is 36. So these two angles must be 36. One more time, straight line, add up to 180. 180 minus this is 144. Divide by 2 actually gets you back to... 180 minus 144 is 36. 36 divided by 2 is 18, which gives these as 18. And this whole angle is 36 plus 18. Which is 90, which is kind of interesting. Question number 8. These questions should really be money in the bank, right? Just do it super slowly, do brackets first, work your way outwards. 4 minus 5 is minus 1. Minus minus makes a plus. Add these together because they're in the bracket. 2 minus 4 is minus 2. Minus minus makes a plus, and we have the answer of 3. Just go super slowly, go from the most constricted bracket outwards. Make sure you just get your negatives right. Should be money in the bank. Question 9, kind of an interesting question here. So all of these, 1 across, 3 across, 1 down, 2 down, they're all 2-digit squares. So let's list all the 2-digit squares. There they are. Those are all the 2-digit square numbers. Now, 3 across is an odd square. Like, what you notice here is that this number x is the last digit of both 2 down and 3 down, and 3 across. So I'm looking for two square numbers that have the same last digit. Now the only things here that have the same last digit are 36 and 16. The problem is 3 across is an odd square, so it's not 36 or 18, or 64 for that matter. It's one of these odd squares, which means actually this number here must be the same as this number here, because these don't share any of their last digits. So actually I need this to be the same number as this, but also I need this and this to be a square number. So I need the first digit of this and this square number to be the last digit of some other square number. So for example, if I put 25 here, 25 and 25, I would need a square number ending in a 2, but none of my square numbers end in a 2. So I can't do that. If I put 49 and 49, that's okay, because this number ends in a 4. So I can use 49, 49, and then put 64, 64 in here, and that all works. So the answer will be x is 9. And you can verify that's the only thing that works if you want to, or you can just move on. 81, 81, there's no other things that end... If it were 8s here, you can't make anything end in an 8 on this list, so yeah, that must be it. Quite a fun question here. I don't know why my brain immediately did this, but this is immediately what my brain did. Okay, and now I just counted that there are 4 triangles that are shaded, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 triangles that are not, which is the same as a quarter. Yeah, I can't really explain that. I think it's just because I've done lots of questions that look a bit like this before. But yeah, sure. Question number 11. A particular prism has 10 faces. Okay, so a prism has 10 faces. Now a prism has to have a face on the front, then it's going to have some stuff around the sides, then another face at the back. So 2 of the faces are at the front and back. So it has 8 faces going around. which means it must be one of those shapes with an octagon at the front and back, and then 8 sides spinning around like this. So it looks a bit like this, right? 1, 2, and then 8 sides in the middle to make 10 faces. Good, so this is the shape. How many edges does it have? Well, the fact that I've been able to Google a picture of this shape, by the way, I Googled octangular prism and nothing came up, so then I just had to Google prism with octagon faces, which was a bit more boring, but anyway. So yeah, now we can just count up. We're going to have 8 corners on this front face, sorry, 8 edges on this front face, 8 edges on the back, and then 8 long edges around the outside, so it's going to be 8 plus 8 plus 8, and we're going to have 24 in total. Cool. Question 12. Pupils in my class work very quickly. Jaslene answers 4 every 30 seconds. So that means if we double this, he's doing 8 every minute. I don't know whether this is a boy or a girl, actually. I'll just call them them. So 4 every minute. Sorry, 8 every minute, doubling up. 8 every minute. So then timesing by 60, because of course there are 60 minutes in an hour. 8 times 60, well 8 times 6 is 48, so add the 0. 480 questions every hour. That's the easy person. He took 1 hour to do questions, going back on what I said already. Anyway, they took 1 hour to do questions, so they did 480 questions. What about Ella, which I'm actually going to be brave enough to assume is a girl? 5 questions every 40 seconds. Okay, so this is a bit more difficult to deal with. But what I did was I halved it, even though that gave me a decimal, but whatever. Halved it, and then I could times by 3 to find per minute. And then I could times by 60. And now I know 7 times 60 is 420, and I know 8 times 60 is 480 because I just did it. So 7.5 times 60 is bang in the middle, must be 450. So after Ella's gone for an hour, she has exactly 30 more questions to do to catch up to Jaslene. So okay, how long does it take her to do 30 questions? Well, we can see here, if we just times this by 6, we get 5 times 6 is 30, 40 times 6 is 240, 240 seconds is 4 minutes. So she needs exactly 4 more minutes to get through the rest of these questions. 13. So, okay, we're looking for the sum of all these outside angles here. Now there are 1, 2, 3, 4, 5 triangles. So all of the angles, including these middle ones, which I don't actually want, add up to 900 because there are 180 in each triangle, times by 5 is 900. Now, I don't want these angles in the middle. Now, if you notice, around here there's a point, and there are 360 degrees around a point. Now, look at how this angle is the same as this one, vertically opposite. This one is the same as this one is the same as this one, and so on all the way around. So actually, the angles that I want to ignore are exactly half of the whole angles around the point, because they're equal to the ones that I don't want to ignore, or just aren't part of triangles. So these 5 angles, in the middle here, add up to 180 because they're half of the 460 around, because they're simply being cancelled out by all of the equal angles opposite each other. So all we have to do is 900 take away those 180 to get 720 in total. Now there are probably other ways to do this. Like as soon as you did this, you could have worked out, well, okay, so the answer is a bit less than 900 because I'm taking away some of these. Is it going to be this much less? Like if you just distributed the angles equally and said you're taking away 5 copies of 60 degrees somehow, then you take away 300 and you get to 600. So I think it was fairly easy to deduce it was one of these two. And then maybe you can just see that these angles maybe look a bit bigger generally than these ones, but again, you don't want to go by looks. Anyway, this was the proper way of doing it, but I think you could have guessed between those two very quickly, I would have thought. And guessing sometimes is good. Again, you don't lose marks for any of this, so if you can get it down to 2 guesses very quickly, a 50-50 chance, pretty good. Anyway, begin with a positive 3-digit number. Divided by 9, subtract 9, my answer is also 3 digits. So essentially, to do some algebra, you begin with a number, divided by 9, take away 9, and that's still bigger or equal to 100, because it's still 3 digits long. Well, okay, add 9 to both sides, times by 9, and we end up with x is bigger than 981. Now, of course, x was a 3-digit number to start with, so that, I think, means you have 19 choices, except because from 999 to 981. Except that's not an option. The options are much smaller. So what have we missed? Because x can't be any number in between these two. What we've missed is, when we divide by 9 and then take away 9, we're still an integer. In other words, when we divided by 9, we were still an integer, which means x is a multiple of 9. right? If you divide something by 9 to get an integer, x has to be a multiple of 9. Like if you do 80 divided by 9, you don't get an integer because 80 isn't a multiple of 89 of 9. 81 is. So x must be a multiple of 9. So x has to be bigger than this, lower than this, or equal to, but still a multiple of 9. Now I know that one is a multiple of 9 because I literally had to do it. 9 times this is that. Next multiple of 9 is 990, one after that is 999, and these are the only three options we'll have. And that'll be our answer. 15, more money questions here. Pile of 2p coins. She swapped exactly half of them for the same number of 10s. Now she has 420. Okay, so if she swapped exactly half of them, that means she has an equal number of 10p and 2p coins. Let's call that number of coins x. So 10 lots of x plus 2 lots of x is 420, because I'm doing this all in pence now. And it's just going to be easier than writing 0.1 and 0.02. So she's got x 10p coins and x 2p coins, and they add up to 420. Now, of course, this makes 12x. Divide by 12. It's non-calculated, so dividing by 12 is a bit annoying. I just halved and then divided by 6 using a bus stop. Pretty easily gave me the answer. And so x is 35, so she has 35 10p coins and 35 2p coins. Again, I'm assigning female status to Alex, which is questionable at best, but in any case. Now, she swapped half of the 10p coins, half of the 2p coins for 10p coins originally, so that means that she must have had 70 2p coins originally. Thus, swapping half of them makes 35. And then, of course, 70 2p coins is 70 times 2 is £1.40 in total. So that would be our answer. Good. So, cube length 10 centimeters. Starting at each vertex, dots are placed along each edge, 1 centimeter rules. How many dots are there in total? Okay, so all you have to be careful of here is that you don't just say there are 10 dots on every single edge and count them up. The reason you don't do that is because let's just say there are 10 dots along here on each edge. Well, how many edges are there? 1, 2, 3, 4. There's 4 in the middle there, and then 4 on the other side. That's 12. 12 times 10 is 120, and that's not an answer. So there must be something wrong with that logic of just saying there are 10 on each side. Now, 120 should have been an answer, but whoever wrote this question was being very generous by not putting the obvious thing on the thing and making you think about it. The reason it's not the answer is because you're double counting dots, right? If you just say there are 10 dots here and 10 dots here, you're double counting this middle dot here. So we have to find a way of removing all of the dots that are double counted, and be a bit careful about it as well. The other issue as well with that logic there is that just cut the square off, or the cube off here. If we just cut it here, this makes a 2 centimeter edge, but a 2 centimeter edge actually has 3 dots. So again, the length of the edge actually doesn't even correspond to how many dots there are, which is perhaps again why the answers are weird. So let's do this very carefully. The first thing I thought was, okay, just counting the corners. Now there are 8 corners here. Each one has a dot on. So there are just going to be 8 dots in the corners. Now, how many dots are you then going to put in the middle section? Now, for a length 2, as we discussed, length 1, 2, if you're not counting the dots on either end, which I'm not because I've just counted the dots in the corners, there's only 1 dot in the middle. And if you had a length of 3, don't count the dots at the end, there would be 2 dots in the middle. And a length of 4, there will be 3 dots, and so on. So for a length of 10, not counting the dots on either edge, there are 9 dots in between. So there are 9 dots on each edge, not counting the corners. Again, it's just 1 less than the length in total. Of course, there are 1, 2, 3, 4, 5, 6, 7, 8 on the back, 9, 10, 11, 12 edges. 9 times 12 is 108. Add the 2 results together, and you get 116 dots in total. There are probably lots of other ways to think about that. So do give it some thought on your own. Maybe even just draw it. I mean, reduce the problem to just a square maybe, and do it in 2 dimensions rather than 3, just to get a better feel for it. That's always a good idea. Just boil down the problem to an easier situation and see whether you get a bigger feel for it. But anyway, question number 17. So this guy, who I assume Lagrange multipliers is named after, should have probably looked that up before I made this video. That's just a thing in maths that's a bit beyond probably most people watching this video, aside from Mr. Winfield. Anyway, prove that every positive integer can be written as the sum of 4 squares. So, okay, every integer can be written as the sum of 4 squares, and you're allowed to use 0, which is very helpful of them to point out. Now, this is one of those questions where you just want to sit here and you want to just try it all, because as long as you think hard enough and try hard enough, you can get them all. So 1 clearly is 1 squared plus 0 squared plus 0 squared. I'm only allowed to use 3 squares. because apparently he proved that you can always do it for 4. 2, well, just put a 1 here as well. 3, just put a 1 there. 4 is clearly just 2 squared and then use zeros. And then I know I can use the next two numbers because I just put 1s here and then 1s in both places. And now 7 becomes a problem because I can't just increase something by 1. I can't jump to 3 squared because that's more than 7. I can't use 2 squared and 2 squared because that's 8. I can't make any negatives anywhere because square numbers are always positive. So I think I just can't do 7. I can do 8, that's 2 squared and 2 squared, I just said that. 9 clearly by just making that a 1. Or by using 3 squared. Interesting. I would have just made that a 1. But anyway, now that I have 9 with 2 zeros, that's actually more helpful because I can then make 10 by putting a 1 here and 11 by putting a 1 there. 12, I think I can use 2 squared, 2 squared, 2 squared. I almost missed this one. So again, you want to do this slowly and carefully. 13, 3 squared and 2 squared, 9 and 4. 14, just put a 1 here. And 15, actually, I decided that I couldn't do. So I couldn't do 7 or 15, but I could do 13 of them. There's 2 that I can't do. It's interesting that 7 and 15 are the ones that I can't do because they're 1 less than 2 to the power n. So again, if you're for some reason very confident at maths and watching this video, have a think about why numbers of the form 2 to the n minus 1 are the first 2 examples of me not being able to do this. Except I guess for 3, which I could do, and 1, which I could do. But maybe there's something about small numbers not being able to get done. Being able to do small numbers just because of some exceptional rules, whatever. Don't know. Have a think about it. Anyway, question number 18. So, yeah, these things have to add to 15, and also the grey boxes have to add to 15. So I thought first, okay, let's just list, triplets that add to 15 from 1 to 9. So I started at 9, 5, 1, and then 9, 4, 2, and then I can't use 9, 3, 3 because I have to use all in different numbers. So then I went to 8, but I stopped here because I thought, well, there's way too much to list. Now I actually don't know how much there is to list. I just stopped because I figured there's probably too much. I mean, 8, 4, 5, 2 would be next, and then 4, 3, and whatever. Okay, too many things. But actually, if these 2 grey squares, or pairs of squares, need to add to 15 as well, there's actually a very limited number of numbers, or pairs of numbers that add to 15. It's just 9 and 6, and 8 and 7. So actually, one of these pairs has to be 9 and 6, and the other has to be 8 and 7. And actually, this list has already helped me out now, because I can't put 9 here. I can't go 9, 6, 8, 7. The reason I can't put 9 here, again, you can think about it if you want to. You can always pause the video whenever you want. But the reason I can't put 9 here is because then this would have to add to 15, and I have to use here either an 8 or a 7. But from this list, I know that I can't use a 9 and an 8, or a 9 and a 7, because that's bigger than 15 already. So 9 can't go here. 9 has to go here or here. Now, this entire thing is just symmetrical, so I could just rotate it around, and that would end up being with the 9 being there. But I'll put 9 there for now, and I'll put 6 there. And then here, now, I'm not sure what to do here, so I'm just going to guess. I'm going to put an 8 there and a 7 there, which makes this have to be 2. 6 plus 2 plus 7 is 15. And now I'm just going to check that I can do the rest of it. Now I'm missing the numbers 1, which I'm going to guess has to go with a 9. I'm missing number 3. Now it can't go here because that doesn't make that 15. 5 has to go here. I'm missing 3, so let's just put it there, and then just hope that 4, actually makes this 15 as well. So this is a complete solution. But let's go back to the point where I just guessed something. So 9, 6. Let's, instead of putting 8 here and 7 here, let's guess the other way around. That puts a 1 in the middle, and then just check whether this works. Well, I'm missing a 2, let's put it with a 9. That means I need 4 left over to make that 15. I'm also missing a 3, let's put it there. That makes missing a 5. And this works as well. So actually both of these situations work. I can't swap the 9 and the 6. And even if I swapped this pair with this pair, that will just create a rotated solution that's the same. So I only have the solutions 1 and 2. And those will be my only 2 answers to this that actually work in the middle square there. 19. In my class, everyone studies French or German. 1/3 of the girls and the same number of boys study German. Now, this is key here, because this means that I can't have, say, 20 girls in the class. Again, you can pause the video and think about why. The reason I can't have 20 girls is because I can't take 1/3 of 20, because I can't cut girls in half. Apparently that's not, fair or ethical. So I need to instead say, in that case, there needs to be a multiple of 3 number of girls. I could have 21. Because then I could third them for 7, or 24, and I could third them for 8. Now, the same number of boys just study German, so the number of boys is also a multiple of 3. Sorry, no, that's not true. Ignore what I just said. That's not true at all. Twice as many boys as girls study French. Okay, now, if 1/3 of the girls study German, and everyone studies French or German but not both, that means 2/3 of the girls study French. Now, twice as many boys study French, and the same number of boys study German as girls do, which means there are way more boys in this class than girls, is one thing that I can think from here, because one language is the same and the other, there's just way more boys. Okay, now at this point, all I did was just start guessing. I couldn't think of any intelligent way of doing this, so I just started guessing. Let's just pretend there are 12 girls. That's a nice multiple of 3 that I can very easily turn into a third by saying there are 4 Germans. Just saying a third of this girls study German, which means, of course, there are 4 boys, because it's the same number. Likewise, this means there are 8 French girls, because 8 plus 4 is 12, the rest of them doing French. Twice the number of this study French who are boys, that's 16. And now just say, well, okay, 4 plus 16 is 20 boys, and 20 plus 12 is 32 people in total, which is one of the answers. So I actually lucked out by doing it immediately. But even if you had guessed 9 girls to start with, because you know it has to be a multiple of 3, you would have just been you would have been in the middle of one of these somewhere. It wouldn't have quite worked out. And then you just go for a higher number to start with. And yeah, trial and error worked quite well there for me, at least. So if you actually worked out how to do this question, you have skills that I just can't even get close to getting. I just immediately went, I can't work at this. I have no idea how you're supposed to do it. Really, write in the comments that I never actually allow you to write in if you want to. I have no idea how you're supposed to do this. All I did was went to the mark scheme after thinking about it for a bit. You're supposed to join 8 copies of each of these shapes together to make cubes, or cuboids, I should say. No idea how you're supposed to work this out. But anyway, this one, if you put it together with this one like this, makes this. And now this is a 2x1x4 cuboid. So if you just do this 4 times and put them side by side, you end up with a 2x4x4. So this definitely works. You can do this. Likewise with this one, you can somehow work out that you're supposed to put them in like this. This makes a 4x4x1 cuboid, so just do this twice, put them up against each other, you get 4x4x2, so that definitely works. And likewise, these next two are even more ridiculous, but if you put those two together like that, you make perfect cube, and these two you make perfect cube, which of course then you can just do 2 of those next to each other, and you'll get your answer. I have legitimately no idea how you're supposed to work that out. You have mad skills if you just did that in your head. Anyway, question number 21. Some fish, dogs, and children are swimming bay, 40 legs in total, twice as many heads as tails, and more fish than dogs, more dogs than fish. Okay, I hope we can agree fish have 1 head and 1 tail, dogs have 1 head, 1 tail, 4 legs, and children have 1 head and 2 legs. Okay, or at least we're assuming that there are no disabled members of these societies. Okay, now, what can we say here? Now, okay, so twice as many heads as tails is interesting to me, because these things have both heads and tails, these things don't, which means there must be much more of these things than these things in order to get twice as many heads, because these things don't contribute to the tails. So let's just make one thing that works. I also noticed the answers are all very small, which means, again, trial and error is just something that I can think is probably doable here, because the answers are small. Let's just try fish 1. Now, there have to be more dogs. You can't have 1.5 dogs, so you're going to have 2 dogs. Children, now this is where the heads and tails thing comes in. I need twice as many heads as tails. Currently I have 1, 2, 3 tails and 1, 2, 3 heads. So I need another 3 heads to make twice as many heads as tails. So this is a solution that works for more dogs than fish and twice as many heads as tails. Except I also need 40 legs. Currently I have 2 times 4 is 8, plus 3 times 2 is 6. I only have 14 legs here. So what I'm going to do is I'm just going to double up my solution. Okay, so here I still have 6 tails, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 heads, that's fine. More dogs than fish, that's fine too. Count the legs then. So 4 times 4 is 16, 6 times 2 is 12, add them together for 28. So again, not enough. So let's triple my original solution. See if this works. The heads and tails thing still works, the dogs, fish thing still works. What about legs? 6 times 4 is 24, 9 times 2 is 18. 24 plus 18 is more than 40. So somehow this was too few legs and this is too many. Now I can't use decimals again, so actually this solution form must be completely wrong. because I've just skipped the answer somehow. So actually, going back to 1, instead of having twice as many dogs, it doesn't say there are twice as many dogs. It says there are more dogs. So let's just jump up to 3 dogs. And then again, get the children in there so the heads and tails thing fits. 4 tails there, 8. So I need 8 heads in total. This doesn't work because 3 times 4 is 12 legs. 4 times 8 is 8 legs, so that makes 20. But actually, that just means I think if I double that solution up, I still have the more dogs than fish thing. I still have twice as many heads to tails, 8 tails, 16 heads in total. 6 times 4 is 24, 8 times 2 is 16, 24 plus 16 is 40 legs. So this is the solution that works with 2 fish. Again, trial and error, not the most elegant way, but even though I'm probably better at maths than most people who are watching, you could have done that just as quickly, I think, because it was just some numeracy, some trial and error. It doesn't really take too much anything that's intelligent. Use the answers to help you. If they're nice and small, you know trial and error is going to be quite a pleasant thing to do. So do try it. Okay, so here we have congruent, which means identical rectangles going around with a square of 44 in the middle. So let's call the length of the rectangle A and the height B. Now, that means that A plus B plus A plus B is 20. In other words, 2a plus 2b is 20. Divide both sides by 2 and you get a plus b is 10. And now there's a few ways to do this, but the most nice way or pleasant way of doing it is to notice that this b could just be moved to there. And likewise, this a is the same as this a, and this is also b. So actually, if a plus b is 10, that means the sides of this big square is just 10 by 10, because it involves 1 length and 1 height of each rectangle. Now that means the total area is 10 times 10 is 100. Take away 44 is 56. And that means the 4 rectangles make 56. Divide by 4 to get 1 rectangle is 14 centimeters squared. Quite a nice little question. We're into the final 3. 4 different positive integers do this. What's the value of that? Now, this question I think is quite hard. You're looking for, now if p, q, r, s are all integers, 9 minus an integer is still an integer. So you're looking for 1, 2, 3, 4 things to multiply, 4 integers to multiply to make 9. Now the first thing I thought of was this. Here are 4 integers multiplying to make 9. The problem is, if you do this, this makes p 8, it would make q 8, it would make r 8, and it would make s 0. Now that's fine, except they have to all be different integers. So that actually doesn't work. So the next thing I thought of was this, 1 plus times 1 times 3 times 3. But again, this makes p 8, q also 8, and it also makes r 6 and s 6. And this still doesn't work because we have copies. Right, they all have to be different apparently. So how do I make 4 integers multiply together to make 9 and not have any copies? I sat here for 30 seconds or so thinking about it. And that's when I realized, actually, I could make 2 of these numbers negative. Because if I do that, each bracket, 9 minus p now has to be minus 1. 9 minus q has to be positive 1. That's different, right? That's going to give me different answers here. So actually, I'm going to get 4 different things here. 9 minus 10 is minus 1. 9 minus 8 is 1, as we've said. 9 minus 12 is minus 3. And 9 minus 6 is 3. These are all different, add them all together, and we get our answer. And that's actually the only way of doing it. So that was quite a nice question, I thought, actually. Yeah, it took a little bit of thought. Cool. Question 24. So, okay, we have, we're looking for the sum of PRQ, which is down here, and PSQ, which is there. Now, we're told that PQ, which is this, equals PR, which is this, which equals QS, which is that. So we've got some isosceles triangles going on here. Now, this whole angle, because of this isosceles triangle, is x. So that whole thing is x. Now, because this is a right angle, this is also a right angle, which means this angle here is 180 minus 90 minus x, which is just 90 minus x. That's this thing here. And this is where the algebra gets a bit complicated. But if this whole angle is x, and this little angle here is 90 minus x, then that means this one, this angle here is going to be x minus 90 minus x. Right? Like if this was 100 and this was 40, this angle would be 100 minus 40. So it's going to be the whole thing, this one here, the whole thing, minus this little bit here. Now 2 negatives make a positive, so this is going to be 2x minus 90. That's this angle here, just up to this line. Now again, here there's a right angle triangle. Sorry, not right angled, isosceles. So this whole angle here is y. But now I have a triangle with angles y, y, and 2x minus 90. But angles in the triangle add to 180. So I can say 2x minus 90 plus y plus I equals 180. Now that makes 2y. Add 90 to both sides to get this. And now if I divide by 2, I get x plus y is 135. But remember, the sum of these triangles, which is x and y, is what I'm looking for. So x plus y is 135, and I have my answer of 135. Very last question. Thought this question was really tough. It took a lot of thinking about, I think. Again, trial and error is going to be part of my solution because you're given some answers. So always go there at some point. But anyway, what I said was, okay, 4 different images, A, B, C, D. Fine. Now, I'm going to specifically say that those are in order of size. So A is the smallest, then B, then C, then D. They're different, so they can't be equal at any point. Specifically, A is the smallest, then B, then C, then D. Now, if I add all the pairs together and I get these answers, this 23 must be A plus B, because I've said those are the two smallest, and the two smallest must make the smallest. Now, 26 must be A plus C. It must be, because it can't be B plus C. B plus C would be bigger than A plus C, because again, these answers are in size order. So the next smallest, the smallest is definitely those two, the next smallest must be those. Now, what about the next smallest, 29? Well, actually, it could be A plus D, or it could be B plus C. I don't actually know. So what I'll do is I'll go backwards. Right? The 35, the biggest one, that must be C plus D. And using exactly the same logic, the second biggest one must be B plus D. There's no other option. Like, there's no way for me to be bigger than that, aside from B plus D, aside from C plus D, which I've already got. Now, I have the 29 to use, and one of the totals are repeated, and the only sums I have left are B plus C and A plus D. But I know that B plus C and A plus D are bigger than these things and less than these things. Both of those pairs are bigger than these and less than these. Like, B plus C must be bigger than A plus C, because B is bigger than A. And A plus D must be bigger than A plus C, because C is less than D. So actually, the 29 must be the one repeated, because they must be trapped in between those two that I actually decided. So this is what the sums look like. And this is kind of helpful, because at this point I'm just going to do trial and error. I'm going to say, okay, which is the largest? Well, I'm actually going to test from this end. There's two reasons I'm going to test from this end. I'm going to say, let's just make D22 the biggest one, and just see whether it works. There's two reasons I'm doing that. Firstly, because I'm pretty sure, having done lots of math challenges, that as soon as they have a question that they know people will do by trial and error, they like to troll you and put the answer towards the end because they know you go left to right. So that's part of the reason I'm starting in the end. The other reason is, it says what's the largest. Now, even if I did 18 and it worked, that doesn't tell me that 19 or 20 might not work as well, which are larger. So I have to go from the largest backwards, because then as soon as I find that one that works, I know it's actually the biggest. So anyway, let's start with D as 22. Now that makes C 13 from this. And then from here, that makes A 13. But I can't have two things be the same. So that just doesn't work. Start with D as 21. That makes C 14 to make 35, which from here makes A 12. But then we look at A plus D. And 21 plus 12 is not 29. So that doesn't work either. Right? It's not consistent. So start with D as 20. That means C is 15 from here. That makes A 11. And then 20 plus 11 is not 29. So that doesn't work either. Lastly, spoilers, D is 19, C is 16. That makes A 10. 19 plus 10 is 29. And the B also works. B is 13 because A plus B is 13, and this is all consistent. So B is 19 is the answer. Thought that was really tough. I thought it was quite a tough paper in general, actually. But really well done for sticking through it and preparing yourself for your junior math challenge. And thank you for watching.